Hello, and welcome to our What's New presentation for the 2018.3 Vivado release. For this quick take video, I'll start by discussing the high-level enhancements to Vivado, including OS support, IDE enhancements, and partial reconfiguration. Then, I'll cover improvements to SysGen, Model Composer, IPI, and our Xilinx IP. Next, I'll discuss the details of synthesis, implementation, and methodology, and I'll finish up with simulation and debug. Let's start with the high-level enhancements to OS, IDE, and partial reconfiguration. Here you can see a table reflecting which OSs we support across various Xilinx software tools. Focusing on just the differences between Vivado 2018.2 and 2018.3, there are just a few changes. Vivado has been fully qualified with Windows 10 version 18.03, and we are pre-releasing version 18.09. 18.09 was just released in October, and we've not completely finished qualifying it. It will be fully supported in 2019.1. On the Linux side, we've added support for CentOS 7.5 and Ubuntu 18.04. I think that pretty much covers the 18.3 changes. On the device side, we want to highlight just a few things. In 2018.3, we are introducing support for Vertex UltraScale Plus with a 58 gig transceiver. We've also moved several devices to production ready, and for those details, I would refer you to UG973. Beyond 2018.3, we're making some changes to our software release schedule. First, we are unifying our release schedule between Vivado, SDX, and Petalinux. Going forward, all three of these products will be released on the same day. Along with this, we are transitioning into 2 releases per year. 2019.1 will be released in the March-April timeframe, and 2019.2 will be released in the September-October timeframe. Our hope is that with fewer releases, there will be less confusion as to when to upgrade. Let's move on to our GUI changes. In 2018.3, we're introducing project summary dashboards in the Vivado IDE. The dashboards are fully configurable using Tcl and are based on the report configuration objects that we introduced in 2018.1. With configurable reporting, you can define exactly which reports are created for each run and each individual step of each run. The project summary dashboards enable you to view and analyze all of this information in one place. Now you can easily see how your timing changes using different strategies or as it proceeds through the flow. Today we support 5 reports and more will be added in the future. I strongly encourage you to give them a try. The Vivado IDE is also introducing native support for high-resolution monitors. In previous releases, we left scaling fonts and icons to the window manager. Often this is achieved by simply scaling the pixels and essentially leaving a fuzzy image. We've upgraded our software stack and no longer rely on the window manager for this scaling. All of our icons have also been updated to scalable vector graphics or SVG format so that they remain crisp as they scale. You should start to notice the improvements on a 2K monitor, and you'll definitely appreciate our efforts on a 4K monitor. There is one outstanding issue if you have 3 monitors running on a native Linux workstation. It may take us a while to correct this issue, but we did not want to hold up this feature for what we expect to be a small corner case. We are also improving access to Vivado Help. We have now enabled the F1 key to bring up help for dockable panes like the Properties tab, standalone windows like our project settings, and wizards like our timing constraint wizard. Quick help should be enough to get you going in the correct direction, but if it's not, it contains links to DocNav for more in-depth documentation. So next time you need help, feel free to press the F1 key and we'll be there for you. Sometimes we try to be a little bit too intelligent for our own good. In previous versions of Vivado, newly created runs defaulted to user custom strategies. Internally, this has caused us many timing closure issues with our SDX toolset, since SDX expects to be using the default strategies. We decided that it would be best to change the underlying Vivado behavior. Thus, any new runs created in 2018.3 will be created using the default Vivado strategies. If you have scripts that rely on the old behavior, please update them to either set the strategy property explicitly on existing runs, or, for new runs, set the custom strategy when you create the run. We wanted to make sure that you were aware of this behavior change so that you could make any adjustment to your scripts. With partial reconfiguration, we're introducing a lot of new device support. We have expanded our Tandem configuration support for PCIe IP. The streaming core now supports all Zynq RFSoC devices, but only using Tandem PROM, since there's no MCAP-enabled PCIe sites. And we have full support for the new RTX 7 devices. The XDMA core supports 7 new devices spanning the Zynq, Kintex, and UltraScale Plus families. Remaining devices will be added in 2019. We are also officially releasing partial reconfiguration support for the VU440 device, although we will likely need a rather large machine to compile successfully. This support had been in place but gated as we finished up tuning and testing. Incremental Compile now supports partial reconfiguration designs. Seeding your implementation run with your previous results may help improve your compile time. Finally, we have a few new example designs for the UltraScale Plus devices. AppNote 1338 shows how to enable fast partial reconfiguration over PCIe, and Lab 7 in UG 947 demonstrates how to use partial reconfiguration from DDR4 or QSPI. Both of these documents will be available shortly after the 2018.3 release. Designing at higher levels of abstraction help bring your ideas to market faster. Let's talk about improvements we've made to SysGen, Model Composer, IPI, and cover some of the new features in our Xilinx IP. In System Generator, we're introducing a new Super Sample Rate, or SSR library. This library includes 25 new blocks that offer greater ease of use, abstraction, and enables rapid design iterations. We are also introducing new reference examples for the SSR library within System Generator using the new Xilinx SSR block set. Examples include a digital down converter using SSR blocks and an inverse FFT using the vector FFT block. System Generator now supports the Zynq UltraScale Plus RFSoC ZCU111 board and the 3 versions of MATLAB listed here. For more information on Super Sample Rate devices and the new Xilinx SSR block library, please refer to the user guide. Moving on to Model Composer. In 2018.3, Model Composer now offers throughput control. Using this mechanism, you can specify the desired number of data samples processed per clock, and the Model Composer will automatically try to achieve this throughput without any structural modifications to your design. We've also augmented our capabilities with respect to importing C or C++ functions. First, we allow you to debug these imported functions using third-party debuggers while the Simulink simulation is running. And secondly, we now support importing functions with arguments of type complex. Finally, we have a plethora of example designs for you to look at embedded directly into the MATLAB help browser. You can use these examples as a starting point to begin importing your own custom functions. We have also added new optimized min, max, and reshape row major blocks to the math functions sublibrary. New mux and demux blocks enable better control over routing in your designs by allowing you to join or split signals from buses. Model Composer supports all 3 versions of MATLAB listed here, and if you want more information, you can find it on xilinx.com/Model Composer. Now let's take a look at some of the changes to IPI in 2018.3. In 2018.3, we've added a new powerful block diagram differencing tool. This functionality can generate an HTML-based report, which users can work with interactively, or a text report useful for revision control systems and your own custom scripts. By using a web browser approach for interactive differencing, multiple users can simultaneously view the report. Simply copy and paste the BD-diff URL, and members from the same network can see the same report. Clicking on items real-time cross-probes to a Vivado IP Integrator block design, even with multiple users. This interactive multi-user differencing is especially useful during design reviews. The HTML-based report also supports advanced filtering, so you can adjust the results to only see what's important to you. We have also worked to make performance improvements to IP Integrator-based block designs. Loading designs, whether they're from BD, using WriteBD tickle output, or a configurable example design, are much faster. In 2018.3, any utility IP such as a slice, concatenate, or constant block will be synthesized automatically using global synthesis. This approach cuts down on the out-of-context design runs overhead, and in larger designs this results in significantly faster build times. Lastly, for IP Integrator, all new designs starting in 2018.3 will be saved in a new JSON file format. We moved to JSON for easier readability of the actual BD file. This should be entirely transparent, but we wanted to make sure we mentioned it. On the IP side, we have significant updates to several IP. I'm only listing the key updates here, and for a full list, please refer to UG 973. I've broken up the IP updates into 4 categories: Foundation IP, which includes XPM, Storage, PCI and DMAs, Wired and Wireless Communication, and lastly, Audio-Video. In 2018.3, HBM adds a cockpit-like GUI for users to do analysis of memory performance. It allows users to easily configure the mode for their specific traffic patterns and adds a full demo mode with dynamic traffic patterns. We've also added fine resolution temperature reporting. On the DMA front, QDMA now transitions to production quality and is available with the Linux driver. In wired IP, UltraScale Plus 58GB GTs now add support for 50GB and 100GB Ethernet and leverages hardened KP4 forward air correction. The UltraScale Plus devices also add 200GB and 400GB Ethernet on 58GB GTs using soft KP4 forward air correction. In wireless IP, we are introducing a new eCPRI subsystem, an example design with an eCPRI integrated into a 10GB or 25GB radio over Ethernet framer on a ZCU 102 board. For audio-video IP, DisplayPort 1.4 subsystems are full-featured and now have the same or more features than DP 1.2 subsystems. For all new designs, we recommend using the DP 1.4 subsystem. We also add UltraScale Plus GTY support. Xilinx now offers comprehensive audio solutions to go along with video. We have added I2S and SpeedDiff audio interface IPs. These IPs are integrated in HDMI DisplayPort and SDI example designs. ALSA Frameworks drivers now support I2S audio and HDMI embedded audio. Let's move on to RTL Synthesis implementation and methodology improvements. In terms of language and compiler support, in VHDL we now support synchronous and asynchronous assignments in the same process. In VHDL 2008, we've added support for generics and packages, generic lists and entities, and we also support functions in a generic of entities. Finally, for System Verilog, we support arrays of interfaces and unions. For implementation, we've improved Fmax and compile times over 2018.1. For multi-SLR devices, we've introduced two new properties to help improve timing on paths between SLRs. First, the user SSL reg property allows you to map registers to a particular SLR crossings. And secondly, user crossing SLR allows you to precisely define the partition. There's also a new router directive called Aggressive Explore, which should be the highest performing router directive. For implementation, we now have an automatic mode for incremental compile. In the project mode, this automatically copies the output of the previous implementation run as a reference for the next run if the design is converging. This should help improve compile times as your design is stabilizing. Report QR Assessment and Report QR Suggestions are two reports that should assist you with your timing closure. Running RQA provides a simple score for your design and should serve as an early indication of the likelihood of your design to meet timing. For scores that are less than 5, RQS should provide suggestions on how to improve your score. Along with the database of expanded suggestions, we've created a new GUI interface for the tool that provides the cross-probing you expect from Vivado and the ability to implement the suggestions with a single click. Also, to support you with your timing closure, we've created an abbreviated quick reference guide to UG 1292. The 10-page guide covers our top timing closure procedures and techniques using a flowchart-centric approach to make it easy for you to understand. Please review the cheat sheets to get your design back on track. Finally, let's cover improvements for simulation and debug. In the Vivado Simulator, we've added transactions to our waveform viewer. For any AXI memory mapped or AXI streaming interfaces, you can easily view the transactions as opposed to the lower-level waveforms for each signal of the interface. We've also added support for displaying System Verilog dynamic types. And finally, we support top module port names in XSI. On the hardware and debug front, there are a few things to discuss. We've added support for enumerated finite state machines in our waveform viewer. By simply adding mark debug to your current and next states of your state machine, you can view the state transitions directly in the waveform viewer. We've also added the RTL instance names for all debug cores inserted or instantiated to the Hardware Manager view. Hopefully this will make it easier for you to find the exact debug core while debugging your design. Finally, in 2018.3, we've added support for indirectly programming ISSI serial NOR flash. To summarize, Vivado 2018.3 contains a variety of new features throughout the entire tool. If you want a 3% higher Fmax with a 50% reduction in compile time, then you should consider upgrading. Or, if you want to spawn off several runs and visually compare the results, our new project summary dashboards will enable you to do just that. If you're designing a new algorithm and don't want to waste your time coding the base functions, then you may want to check out our new SSR block library and system generator. And finally, if you just want to know what changed between two versions of your block diagram, our new BD diffing tool will be priceless. For more details, please take a look at our release notes in UG 973, and more importantly, you can download the latest version of Vivado at www.xilinx.com/download. Thank you very much for your time, and we hope you enjoy the new software.